So let's assume that we suspect at least a linear relation based on a scatter plot. Then we may want to calculate what's called the correlation coefficient. And for a sample, we use a lowercase r. So the correlation coefficient, if you had to calculate it by hand, it's a somewhat complicated formula. I'm going to write it down here, but really we're going to use technology to do this calculation. So you may notice that in statistics, a lot of our calculations involve a sum, so we see this Greek letter sigma quite a bit. So for the correlation coefficient, we'll take the sum of a product. And so the first factor in this product, it's kind of like a z-score for all for an x for a value of our x variable. So we'll take x, one of our x values, look at its difference from the mean, and then divide that by the standard deviation among all the x values. So this subscript of x means that this is the standard deviation just among the x values. So remember that we're starting with two variables. There's x and y. So this would be just the standard deviation here, and just like x bar is just the mean for these values. In the other factor, I look at the standardized y values. So this is y sub I minus y bar over the standard deviation among the y variables. So again, y bar would be the mean just for these values, and s sub y is the standard deviation just for these values. And that's all divided by n minus 1. So we're kind of taking an average by summing and then dividing by how many we have. So a few things that you should know about the correlation coefficient is that it is always between -1 and 1. So that's the first thing I'll point out. And -1 indicates a perfect negative relation. Perfect negative linear relation. And so in our scatter plot, that would look like this, where we have things that line up perfectly along a line with a negative slope. And +1, on the other hand, would indicates a perfect positive linear relation. And so that's when we, in our scatter plot, would see points that line up just perfectly along a straight line with a positive slope. If we have a value of 0, then that indicates no linear relation. Now that doesn't mean that there's no relation, it's just not linear. So going back to something I mentioned before, here we had something where there's definitely a pattern. It's parabolic, there's a quadratic relation. The value for r here would be 0, but there definitely is a relation, there is a pattern there. So when you interpret r, be careful when you have values close to 0. It doesn't mean that there's no relation, just no linear relation. I would also mention that the correlation coefficient r is not resistant. So if you have extreme values, they can impact r. And another little sidebar here, this may come in handy. The Greek letter rho, which kind of looks like this, almost like a P shape, rho, that would be if you had population data and could calculate a correlation coefficient for the population, you would use the symbol rho. That's analogous to when we have the standard deviation and we use S for a sample and sigma for the population, or how we use x bar and mu for the mean. There's a separate symbol when we calculate the correlation coefficient for our population. Now, I wouldn't ask you to do this by hand, so let me show you how you can do this in a calculator. And I'm going to just enter a simple data set. One, making up some numbers, 7, 10, 15, and I'll put in some values, 99, 87, 65, 52, 29, and 12. So let me show you two things here. First of all, how we can look at the scatter plot, and then visually we can think about whether or not there's a positive or negative association and whether there's a linear pattern or not. And then I can show you how you can find the correlation coefficient R. So I'm going to turn on my stat plot. So I'm hitting second and then this function button on there with stat plot there. I want to make sure that this is turned on, and if not, I would move my cursor from off to on. I want to make sure that the type is scatter plot. There are other options here for histograms and box plots, and I also want to make sure that it says that my x values are in list 1 and my y values are in list 2. And I think I'm good to go. So to actually look at the stat plot, I can hit zoom and then scroll down to option number 9. And so here's the scatter plot for that data set that I just made up. And notice that there is a downward trend. So there's a negative association. And I think this is you might say that that's a close to a straight line in the pattern there. So in order to check the value of R, I'll go back to my stat menu, scroll over to the calculations, and the fourth option here says LINREG. That stands for linear regression. And if you don't have prompts, you may have to indicate where your data is. Mine is in list 1 and list 2. Those are my x values and y values. I separate that by a comma. To type in L1 and L2, I use the second key, and then when I hit 1, that puts L1 there, and then second 2 puts the L2, hit enter. And so the last value here is R. So for me, in this case, R is 0.9747. I'm just going to keep 4 decimal places. So this is the value that's pretty close to 1. Oh, I actually made a mistake there. That was negative 0.9. And again, if we go back to our scatter plot, yeah, that makes us, we were expecting a negative association here. So R would indicate that negative trend because it is a negative value. So I also want to show you, even though this is very close to -1, so it's close to what would indicate a perfect negative relation, how we can determine whether this indicates a linear relation or not. So this is a process. Let me move my over here. To determine whether or not this indicates a linear relation. First of all, you will take the absolute value of R. In other words, in mathematics notation, we put these bars. So in this case, I would just drop the negative and say that we're looking at 0.9747. And secondly, I'm going to look up a critical value, which I'll abbreviate CV, in a table. And so I have a table somewhere here. Let me show you what that looks like. The table is rather simple. It just has usually 2 columns. Let's see if I can show this to you. You'll need your sample size. Now, in this data set, I think I just had, let's see, 1, 2, 3, 4, 5. I had 6 values. So I'm going to put on here based on n. That's your sample size. So here's an example of a critical value table for the correlation coefficient. My sample size was 6. And so you see right next to it is a critical value. This is 0.811. So 0.811. So the way that we'll make a decision about whether there's evidence of a linear relationship is we'll say if the absolute value of your correlation coefficient is greater than the critical value that you look up, then there is evidence of a linear relation. Okay, so if we decide there is a linear relation, it would be nice if I had the equation of the line that would best fit or approximate this data. And we'll discuss that in the next video.